Hi, so this lesson is about solving questions using logarithm. So, how do we solve logarithm of a given base? So, as we have learned previously, to solve an equation is to find the value of x. So, if 2 power x equals 6, we can actually convert this index equation into a log equation, which will become x equals to log 2 6. Yeah, so log 2 6 actually gives us a value of 2.58. So how do we do that? How do we know that? We can actually use the calculator to actually get this value. So if we use the TI Inspire CAS student calculator, and if we go to the log function, so we just have to press Control and 10 power x here to get to the log function. So log 2 6 will give us a value of 2.58496, and I actually round this up to 2 decimal place. Yeah, so for the second one, 50 times 1.1x equals to 100. So 50 times 1.1x equals to 100. So in order to simplify this, we are bringing 50 across the equal sign. So it becomes 1.1x equals to 100 divided by 50, which is 2. So that means that 1.1 power x equals to 2. And if we convert this into a log equation, it's going to be x equals to log 1.12. So if we put this into the calculator again, this is going to be 1.1 and that's going to be 2. So this is going to give us a value of 7.27 if rounded up to 2 decimal place. So if we look at the next one, solve using base 10 or ln. Yep. So the same question can actually be solved using base 10 as well. So there are many ways to solve this depending on the requirement of the question. So as I said, this is the same question, 2x equals to 6. And if we put a log base 10 on both sides, we haven't changed the value of this equation because we're just adding log base 10 on both sides. So that's going to give us log 10 2x equals log 10 6. Yep, and we learned previously from the logarithm rules that we can actually bring the exponents to the front of the log, which is the same. So if we have done this, it's going to be x log 10 2 equals to log 10 6. And now to get the value of x, all we have to do is use log 10 6 divided by log 10 2, and that's going to give us the answer 2.58. So if I go to the calculator function, so I can go to control log 10 6 divided by log 10 2. So that's going to give us the answer of 2.58, which is similar as well. So you must be wondering, why are we using a log base 10? Well, that's because some of the scientific calculators comes only with log. So if you see a log without the base, the automatic value is actually 10. So if you are using a scientific calculator, all you can do is put a log 6 divided by log 2. You will get the same answer as this one. So since we are doing this, let me introduce you to the idea of ln as well. So this is the ln function over here. So a ln function is actually a log with a base e. Yeah. So if we use a ln function, so if we use a ln 6 divided by a ln 2, it will give us the same answer as well. So this is going to give us just a minute. So this is also going to return a value of 2.58. So it's actually many ways to get the same answer. So it depends on the question. Yep. So if the question says solve using base 10, you have to solve using base 10. So let me just get to the second question. So the second question is also the similar question as what we have done before, solve using the given base. So we have to simplify the equation first, yep, and then after that we have to add a log 10 on both sides. And then after that, we have to move the x to the front again, as what we have done before. And then to find the value of x, all we have to do is use log 10 2 divided by log 10 1.1, and that will give us the answer. Yep. So let's look at how do we solve an exponential decay question using log. Yeah. So if we have a question that's like a cup of boiling water is placed on a table to cool. The temperature T degrees Celsius of the water T minutes after it is given by the equation T equals to 20 plus A times 0.94 T. So given the boiling point is 100, find the value of A. So what we're doing is, this question is asking us, for example, if we have a boiling water and the boiling water is at 100 degrees Celsius and we place it on a table so that it cools down. So it means that the temperature is actually dropping, and therefore this is actually an exponential decay. So as learned previously, how do we know that this is actually a decay function? This is because this value over here, the base number for the index is between 0 and 1. So this is sort of like the meaning of it's actually dropping by at a rate of like 6%, like at the rate of 0.06, which is 6% every single minute. Yeah. So initially the water is boiling at 100. So at initially, so this is the temperature of the water at a given point. So we put 100 at here, at the temperature T here, equals to 20 plus A, it's a constant that we have to solve in this case, and times 0.94. The reason why we put 0 here is because it is initial. Initially means when time equals 0. Yeah. So in order to solve this, we have to move 20 over the equal sign. So I have a typing mistake here. It's actually 100 take 20 equals to A times 1. Yep, that's because any number powered by 0 is 1. So we know that A has a value of 80. Yep. So A has a value of 80, and if you substitute 80 into your A, and then what happened is I'm just drawing this curve using Desmos, and you can see that this is actually an exponential decay curve. Yeah. So we learned previously from exponential decay that if we don't have this 20 value, yeah, it's gonna be how do you say, a decay curve with a horizontal asymptote of like y equals 0. So it means that it will approach 0 but not touching it. Yep. So the second question is, what is the significance of the constant term 20? Explain. So if we draw this, we know that it's going to be this curve. So the constant of term 20 will be, it is actually vertically translating this decay curve up by 20. So it will mean that the temperature will keep falling until it almost reaches 20, but it will not reach 20. So y equals 20 is actually the horizontal asymptote. So this could be logical, maybe because the surrounding temperature is 20. So as long as the how do you say, the water cools all the way down up to room temperature, that's when it stops cooling down. So that's why the curve stops going down after it sort of reaches 20. So what is the temperature of the water after 5 minutes? So after 5 minutes, so this is when my time equals 5, because in this case the unit here is minutes, so we don't have to convert anything. We just have to substitute 5 into the equation. So our equation is T equals to 20 plus 80 times 0.94. So instead of writing T, I'll just put power 5. Yeah. So if you put this in the calculator, it's going to return you the value of 78.7. So this is the temperature of the water after 5 minutes, and I've corrected it to 1 decimal place. So to the nearest minute, when will the temperature drop to 40 degrees? So if we want to find when the temperature will drop to 40 degrees, we know that time, the capital T is 40, and now we have to find the lowercase t here, which is when is the time. Yeah, so by substituting 40 into the uppercase T here, we get this equation, which is 40 equals to 20 plus 80 times 0.94 power T. And then to simplify this, I am actually moving my 20 across the equal sign. So that's 40 take 20 divided by 80 over here. So this is going to give me a 0.25 equals to 0.94 power t. So after we have reached this point, we have to use log to solve the following. Yeah. So if I add log at both sides. So in this case, I didn't write base 10, so it is assumed that it's base 10 already. So I add log on both sides. And also, can you see that I have moved the t down to the front of log? So yep, that can be done because according to the log law, they are the same. Yep. So now in order to find the value of t, I'm actually using log 0.25 divided by log 0.94. And if I put this into the calculator, it's going to return me a value of 22.41 something something. And if I actually round it up to the nearest minute, it's going to give me 22 minutes. So this means that at the 22nd minute, the temperature will actually drop to approximately 40 degrees Celsius. So yeah, that's the end of our lesson today. And yeah, keep going, keep studying, and stay safe. See you then. Bye.